In this lesson, we will learn about statistical or ranking functions. This is part 1 of the video where we'll look at percent rank, cumulative distribution, and row number. So let's get started. So statistical function help in identifying the distribution or rank of a column, which will be labeled each record in your data. So for each row, you would have certain rank or distribution attached to the data. So we can do this in using multiple functions. For example, we have percent rank, which provides the percentile rank of a record in a defined position or partition, right? We can calculate the percentage of value less than the current value. So we will be ignoring the current value in case of percent rank. The outcome values are restricted between 0, 1, where 0 refers to the lowest rank or the first value, and the 1 refers to the highest rank or the last value within your partition. We'll understand this with an example. It will become more clear even if you are not following this yet. Then we have cum_dis, which is like a cumulative distribution rank. We can calculate the percentage of values less than or equal to the current value is calculated using this formula. Again, the outcome values are restricted between 0 and. Now let's try an example problem using our employees detail table. You are already familiar with this table. I have copied over a small subset of data here. So we have employee ID, first name, last name, department, and salary of the employee. Now we want to get the percentile rank and cumulative distribution of employees working in the clothing department based on their salary. So let's focus only on the clothing department. So what you see here is the data set for the rows for clothing department. Now I have sorted the salary based on low to high because we want to find rank. That's why we have sorted. And now let's think how we can calculate the percentage rank for each of these values. Alright, we know that based on the definition, the first value will have a rank of 0. So we have assigned 0 rank by default. Now the next thing is we want to find the percentile rank for the second, right? Now in order to do that, we need to calculate percentage of values less than the current value. So we have to ignore the current value, right? In total, if you see, there are 3 values or 3 rows, but -1 because we have to ignore the current, hence there are the 2 rows here, right? And only one value is less than the current value. The current value is 72,000. One value less than is 72,000 is 28,995, right? And only one value less than this value. Hence, we calculate the percentile rank as out of these 2 values, only one value is less than the current value. So it is 1 by 2. Only 28,995 is less than the current value, and your total values, if I ignore the current row, are 2, right? This row and this row. So which means that we have to divide 1 by total rows ignoring the current value, which is 2. 1 by 2 is 0.5. Right? Finally, because we know by definition the last value is always 1, so percentile rank is 1 for the last row. Now let's get the cumulative distribution. So we need to calculate the percentage of value less than or equal to current value. Previously it was only less than. Now we are talking about less than or equal to the current value. So it seems out of 3 value, there is only the current value itself that satisfies this condition, right? For the first row, the value less than or equal to the current value is only one row, which is this one. So the value for this will be 1 by 3 because we have total 3 rows in this, right? Because the current row is also counted when we talk about cumulative distribution. So it will become 1 by 3, which is equal to 0.33. Now, can you calculate this for this record now, second record? Now you can pause the video, then proceed once you have calculated the value. Alright, let's see if you got it right. We need to calculate the percentage of values less than or equal to the current value, right? So out of the three values, we have two values which are less than or equal to 72, right? This row and the previous row. So the cumulative distribution will be 2 by 3 for this. And 2 by 3 gives us 0.666, right? And now coming to the next row, we can see that the last will obviously be 1. This is quite straightforward, right? Because there are 3 rows which are less than or equal to this 3 and total rows are 3, so it will be great. Let's now observe how to write the query for the large data table of that meta. Alright, so we will be reading data employees and detail table. So let's quickly look at the data. This will contain the employee details. It has quite a lot of columns. What we are concerned about is employee ID, first name, last name, department, and the salary, right? So now let's get started. So we'll be creating percent rank and cumulative rank for distribution. I can select and I can select my columns, which is employee and ID. This is our first column. Then we'll select name, last underscore name, select department, and salary. Alright, now we will be using our function percent underscore rank, right? Now this function, we don't need to provide any column here, right? Because it will just rank based on the order we provide within the partition. So I'll just use over and I'll partition by department, right? Because we want to find this across department. So I'll partition it by department. Now order by is important because this ranking will be based on order by, how we order it. And we want to order it by salary. And we will rename it as percent rank. And then the other function is cum underscore distribution, right? And then again, here also I don't need to provide any column. I just need to provide the partition, which is partition by department and order by salary. By default, it is ascending, which is low to high. And let's call it relative. Then we'll read our data set as detail. And we will filter it because we want to look at clothing department. So we'll do department equal clothing. Right now, let's run this. Alright, so we can see that for clothing department, the data is sorted based on salary. And we can see the percentile. So we have a lot of rows. So the way it is calculated is, in case of percentile rank, it will not consider the current row, but in case of cumulative distribution, it will consider the values less than equal to the current row. Alright, now let me introduce you to another function, which is row number. So this function is used to assign unique ranking to each record within the partition. It is very straightforward. It is like assigning a row number to each row within your partition. Now let's try to understand this with an example. So let's say we have to give each employee a unique ID within each department so that they can participate in office events. The idea is that we should have a unique identifier for each employee in the department. So I have arranged the rows for you so that it's easy to get the department-wise breakdown records. Right? Let's figure out the respective unique ID. So for clothing department, right? Let's say our data is sorted by employee ID. So we'll give unique row number to these. The first row is given rank of 1, second row 2, then 3. Right? Similarly, we can do the same for sports. The first row is given rank of, second given 2 rank. Right? And third tool has only one row, so it is given the 1 rank. Right? Now let's go to the database and let's see the query. Alright, so we'll be looking at row number. So I'll select the column. Let's say we select every column. Now we'll use row number, row number. Again, we don't need to provide any column. It will give the row number based on the order that we provide within the partition. We need to partition it by department, and I can order it by employee ID. Descending is not what I want. I just want it to be basic low to high is ascending order. Let's say this is called as you and read our data table is employee detail. The output. All right. So our data is partitioned by department and we've sorted it by employee ID. So employee ID 23 is having row and then 90 is having row like this. A row number is assigned for each of them within the department based on their employee ID in the ascending order. Now for the second department, beauty again, the row value started from 0, from 1. Right now again from 1 to the total number of employees that we have at the beauty department will go to. Alright, so let's summarize. So we looked at 3 functions. One was percent underscore rank. So it provides the percentile rank of a record in defined partition. Then we looked at cumulative distribution. It defines cumulative distribution within the defined partition, then row underscore number, which assigns unique rank to each record within our partition. Okay, so this is the basic syntax of these functions. We have the function name, then over our partition, order, whatever you want to provide. Alright, so that's all of this session. In the next session, we will look at over the ranking function.